Good afternoon, everybody. Today we will see the chapter photochemistry. Photochemistry chapter is very important chapter in our BSc students because we know that photon, the reaction of light in interaction of light in a chemical reaction is very important. The definition is that the interaction of light with a chemical substance to give the product. Now, we know that there are various types of photochemical reactions. Number one is photosynthesis reactions. In photosynthesis reaction, 6CO2 plus 6H2O in presence of ultraviolet light gives glucose and byproduct as oxygen molecules. In this case, what happens? The H mu is a ultraviolet light, and in photochemistry chapters, the region of the photons means what? UV, visible, and near infrared region. Near IR radiations are very important radiations in the photochemistry chapter, or we can say that these three types of regions are very important in photochemical reactions, any type of photochemical reactions. In this case, now second example is decomposition of chlorine into radical. Chlorine radical is using the ultraviolet rays. Ultraviolet rays is generally used in the radical formations. Visible light is generally used in the photosynthesis of plant. Like here, we use the visible range, and near infrared reaction is some Nash type 1, Nash type 2 reactions. We can use near infrared radiations. In photochemistry, there are two-step process. One step is primary process, and second is a secondary process. In primary process, what happens when light radiations incident on molecules, then the electronic state can be excited. And in secondary process, what happens? In secondary process, after the excitation of the molecules, the electronic state get excited, and after the excitation state of electronic state, after that, what happens? The breaking of bond or making of bond or reactions can be takes place in a secondary steps. In secondary steps, second step start, and also we know that the chain reaction. Chain reaction is what? Suppose free radicals are there in the reactions, they can decompose other molecules of the molecules, and they can also generate the radicals. This continuous change takes place in the secondary process, and primary process is very important process. Without primary process, secondary process does not take place. Now, the photochemistry chapter, there are two laws of photochemistry. Number one is a Grothus-Draper law. This law is also called as the first law of photochemistry. Now, this law explains that if light radiation is incident on molecules, they can be absorbed. If they does not absorb, the reaction does not take place. Suppose no light absorb, no reactions, or suppose you know that in sunlight or in any type of the light, there are various types of radiations: UV, visible, IR, microwave, etc. But the molecule can be absorb only visible type of the radiations. At that case, if you provide the UV light, at that time the reaction does not take place. Means that only particular type of radiations are essentials for the chemical reactions. This law is explained by the Grothus-Draper's law. This law is also called as the first law of chemistry, photochemistry. Now, the second law is Stark-Einstein law. This is the second law of photochemistry. The statement of this law is for each photon of light absorbed by a chemical system, only one molecule is activated for photochemical reactions. Means that in photochemical reactions, photon is when one photon is present in the light radiations, the only one molecule is activated. Only one molecule is activated. That is one photon, one excited molecules, or a single molecules. This step is explained in the as a primary process. This step actually explain the primary process. Means that this second law, Stark-Einstein law, explain the primary step of the reactions, primary process of the reactions. Now the next part is in our chapter is quantum field. Quantum field is very important terms in the photochemistry which can express the efficiency of the photochemical reactions. These quantum fields explain the efficiency of photochemical reactions and which depends on the number of molecules reacted upon number of photons absorbed. We know that photons and molecules are very important in photochemistry. Number of photons, number of molecules activated. This ratio explains the efficiency of quantum field, and this symbol is called as a phi. Now this phi, the ratio is phi, this value is less greater than 1, at that time we can say that number of photons decomposes more molecule than the photons. More molecules decomposes in this ratio, means more molecules decompose. That means in this case quantum field is high, and in this case if the quantum field is less than 1, at that time less amount of molecule decomposed by the photons. Less amount of molecules decomposed by the photons. That is, this value is less than 1. Now we can now see the Joblowski energy level diagram. This energy level diagram, very important diagram, which reveals how the molecules is absorb the light, excited state, and re-emit the light. This phenomena can be explained in the Joblowski energy level diagram. That means interaction of light with the molecules can easily be understood by the Joblowski energy level diagram. Now in this diagram we can see that this is a ground state. This H0, S1, S2 are the singlet. S for the singlet. This is a ground level energy level diagram, and when light is incident on the molecules, at that time the electrons get excited from this level to this level, means singlet S1 phase. Now the upper level is a singlet S2 level. These are the energy. These are the energy level diagram. And now what happened in this case, when in singlet molecules the pair electrons are pair in natures, and when the molecules get excited from these two this and these to this, at that time what happens, after some times the molecules get deactivated. When the molecule deactivate to the original state, the step is from S2 to S1 or S1 to S2. At that time, this step is called as an internal conversion system. Internal conversion system. In some cases, what happen? This is a vibrational energy state. In vibrational energy state, what happen? When molecules get electronic structure get vibrated, at that time the energy may be lost as heat to the surrounding or other electronic structures. At that time, these molecules get deactivated from this point to this point. This is a vibrational energy state. Now, this S1 stage or singlet S1 stage is very important in photochemical reactions. In this case, what happens? The electronic structure is unpaired. Singlet is a pair electrons, and when they goes to the T1 state is a triplet state. T1 is a triplet state. At the triplet state, the electrons is unparallel to each other, and singlet is parallel to anti-parallel to each other. In this case, the T1 state energy level is slightly less than the S1. Now, if S1 from S1 to S0, at that time some light radiations are emitted. And that light radiations is called as this phenomenon is called as a fluorescence. This phenomenon is called as a fluorescence. This fluorescence having the lifetime period is 10 raised to minus 9 to 10 raised to minus 7 seconds. That is, here is a emission of light. Emissions of light. And that light is nothing but the fluorescence phenomena. And in this case also, triplet state is also responsible for the emission of light. But this rays is called as this emission of light is called the phosphorescence. This phosphorescence having the lifetime period is 10 raised to minus 3 to 10 raised to power 2 second. Means that phosphorus take the longer time than the fluorescence. Phosphorus take the longer time than the fluorescence. And we know that in photochemical reactions, this part is very important. This part is very important. Why? Because in this case, any chemical reactions takes the light from this region only. Take the light from this region only. This is a single state, this is a triplet state, and this is phosphorus. Now in this case, the geometry diagram, there are two processes: reductive process, non-reductive process. Reductive process is what? Fluorescence and phosphorus are the reductive process, and non-reductive process is the internal conversion system and intercrossing system. In this case, light emissions or emissions of light does not take place in non-reductive process, and reductive process is the fluorescence and phosphorus. These are the reductive process. Now, the next point is photosensitizer. As the name indicates, sensitizer means this is a very important in the photochemical reaction term. For what is meant by photosensitizers? Now, according to Joukowski diagram, we can explain that T1 to S0 at that time, what phenomena happen? Phosphorescence. And in this case, what happened? Phosphorescence having the time period is 10 raised to minus 3 to 10 raised to power 2 seconds. Means much longer time than the fluorescence. Now, what is meant by photosensitizers? Photosensitizers, you know that photosynthesis reaction of plants. What happened in this case? The chlorophyll act as a photosensitizer. Chlorophyll act as a photosensitizer. Means what? Actually, in photochemical reactions, this is act as a catalyst. Photocatalyst. Photocatalyst means it does not take part in the reactions, but it help or initiate the reactions. Now explain in more details what is the what in this case. Now you know that in PDT, photodynamic therapy. In photodynamic therapy, what happened? In that case, porphyrin rings act as a cytotoxics. Cytotoxics means what? They can kill the cells. When porphyrin rings act as a photosensitizer, in that case what happen? When the molecule from excited state T1 to H0, at that time phosphorylations are takes place, and these electrons energies are helpful for the other molecules or biomolecules to produce the oxygen, reactive oxygen species, ROS, reactive oxygen species, like a free radical, like superoxide, which can kill the cells in our cells of the tumor or microbe. Microbe is antimicrobial. Bacteria also can be killed by this ROS. Reactive oxygen species are the generated in the phosphorylations process. Now, in this photosensitizer, PDT, photodynamic therapy, what happened? The oxygen molecule is triplet in state. Generally, in surrounding, the oxygen molecule is triplet in state. When photosensitizer like porphyrin rings, which can this oxygen can convert it into singlet oxygen. Singlet oxygen is very reactive, very reactive. So it can act as a cytotoxics in nature. Reactive oxygen species act as a cytotoxics in nature, and photosensitizers also transfer the electrons or transfer the energy. In this case, photosensitizer material transfer energy like these oxygen molecules converted into very reactive oxygen molecules, and here electron transfer of electron is which can helpful for the generation of reactive oxygen species like superoxide radicals. Now in this way we can cover the photochemistry chapters.